Very good morning to one and all present here. I'm Manisha, Assistant Professor, Department of CSE, RMDEC Engineering College. Going to explain here about the microcontroller and embedded system subject under the topic Unit 5 ARM processor. So coming to ARM processor, what is ARM processor? ARM processor is the first encounter advanced RISC machine. First RIS microprocessor for commercial use, market leader for low power and cost sensitive embedded application. So all these are ARM powered products, ARM applications. And what all the features will have ARM features is architecture simplicity, which allows a very small implementation, which results in very low power consumption. Coming to history of ARM, it is developed by Acorn Computer Limiters of Cambridge, England between 1983 and 1985. Problems with CSE, slower than memory parts, clock cycles per instructions. So the history of ARM's solution is the Berkeley RISC-1, competitive easy to develop, less than a year. It is cheap. It is pointing the way to the future. So ARM architecture, typical RISC architecture, will be having a large uniform register file, load store architecture, simple addressing mode, uniform and fixed length instruction field. So enhancements, each instruction controls the ALU and shifter, auto increment and auto decrement addressing mode, multiple load store execution, conditional execution. So what are high performance, low code size, low power consumption, and low silicon area. So pipeline organization in ARMS is increases speed. Most instructions executed in a single cycle. Versions are it is categorized into three stages. Three-stage pipelining, five-stage pipelining, and six-stage pipelining. So ARM 7 architecture and ARM 9 TDMI and ARM 10 TDMI. So pipelining organization, if it is three-stage pipelining, it is categorized into three processes: fetch, decode, and execute. 3-cycle latency, one instruction per cycle through. So if it is three-stage pipelining, first the process is fetch, and then the next process is decode, and then when it is for combination of having decode process, another cycle will be executing fetch, and then the remaining at the clock cycle it will be executing decode. So at the third cycle, when fetch, decode, and execute, again the second process will be starting if the fetch, and again when the last process finish, it completes into the first execute. So in this way, simultaneously the organization, so when compared to other organization, this pipelining organization will have 3 stage. So compared to 3-stage pipelining, 5-stage pipelining is very effective, reduces work per cycle, allows higher clock frequency, separates data and instruction memory, reduction of CPI, average number of clock cycle per instructions. So it comes in an hierarchical way: fetch, decode, execute, buffer, write back. So these comes under 5-stage pipelining. So pipelining flushed and refilled on branches, causing execution to slow down. Special feature instruction in instruction set eliminates small jumps in code to obtain the best flow through pipelining. Operating modes. Thank you.